Hello all, myself Professor Girish Navale. I'm working as assistant professor in computer engineering department of AISSMS IOIT. Today I'm here to give you the introduction of conversion of Melay machine to Moray machine. In this video, we are going to see how to convert given Melay machine into Moray machine. So let's see. So here you can see uh, that Melay machine is given and we have to convert that into Moray machine. So basically Melay machine is a machine where input and output both are outside, where input and output both are outside of the state. And in Moray machine you can see the input is outside but the output is inside the state. That is the difference between Mealy machine and Moray machine. Now we'll see step by step how to convert the machine, right? So here you can see that state S0 has input B and output 0. State S1 has A as input and 0 as output, as well as it has self loop. That means A as input and 1 as output. Similarly, S0 also has incoming arrow from B/1. That means B is input and 1 is output. Okay. So here uh, we need to check how many outputs are possible for every states. Okay. So let's see how many outputs are possible. S0, that there is B/0. That means there is one output possible, that S0/0. Again, there is one incoming arrow for S0, that is B/1. So I can say for S0, there is one more output, that is S0/1 is possible. Okay. As S0 is a start state, we can say that S0 is also having incoming arrow with input epsilon. So I can say S0/epsilon is also one output. Okay. So we split that state S0 into three parts: S0/epsilon, S0/0, S0/1. Now we'll move to state S1. How many incoming arrows are possible? Yes, there is one A/0. So we can say that S1 has one output, S1/0 possibility. Again, for S1, there is a self loop given. So we can say output of S1/1 is also possible. Okay. So here we split S1 into two states, S1/0 and S1/1. Okay. Now we'll just connect the splitting part together. Okay. So S0 is going to S1. S0 is going to S1. That's why we can say that all the parts or splitting part of S0 is going to S1. But where it is going to S1? A/0. That means it is going to S1 for the input A and its output is 0. So I can connect all S0/epsilon, S0/0, S0/1 to S1/0 for the input A. Again, S0 is going to itself, but where it is going to itself? For the output 0. So output S0/0 is the intermediate state. So we have to connect S0/epsilon and S0/1 to S0/0 for the input B. Again, it is self loop, so we can connect S0/0 to itself for the input B. Now uh, S1 is coming to S0 for the input B/1. So we S1 is coming. So there are two states possible, S1/0 and S1/1. They are coming to S0. They are coming to S0 for the input B. So I'm connecting all the S1 part of uh, S1/0 and S1/1 to S0/1. Why? Because it is coming to S1 B. It is coming to S0 for the input B/1. So the state is S0/1. So we are connecting S1/0, S1/1 to S0/1 in this way. Again, S1 is a self loop. So we can say S1 is going to itself. So it is going to for output A/1. So we are connecting S1/0 to S1/1 for the input A. So in this way, we are just connecting the splitting part together. Now the second diagram, you can say it's a conversion of Mealy machine to Moray machine. So in this way, we have done the conversion part.